Alright, today guys we're going to be working on our Unit 6 Math, and we'll be covering 4 standards, and this was made by Alex Hewgley and John Houk. First standard will be covering solving linear and quadratic equations. There are 3 things you need to know when solving linear and quadratic equations. Each system of equations contains 2 or more variables to the problem. The variables are the points at where both equations intersect on a graph. For the equations to be right, the variables must be true in both equations. For our first example, you can pause the video if you want, if you know how to do this, but we're going to be solving by substitution, and we'll get right into the answer. So for our first part, we had to take the negative 37x minus 11 and put that where the y would be for it. So we're subbing in that equation as y. So we're setting them equal to each other. So then we move the like variables onto the other side, setting that y is equal to 0. So then we did 0 equals x squared minus 12x plus 32, which we then completed the square and did x minus 8 and x minus 4, which are our first two x's, which is x equals 8 and x equals 4. We plugged in both of those to either equation to show that they both can work. So negative 37 times 8 equals negative 296, minus 11, which equals negative 307, which is our corresponding x to 8, which is our y, negative 307. And then for our other y corresponding to x4, we got 16 minus 196 plus 21, which equals negative 159. And that will be our other y. This one will be solving by elimination. Pause the video if you feel free so to do. We're going to get on with the answer. So what we did was we subtracted or got rid of the y squared altogether. So we took out the positive y squared and the negative y squared, and we added all the common variables, which is x squared and 29 and 3. And we got 2x squared equals 32, which then that whole equation can be divided by 2, getting rid of the 2 on 2x squared, and 32 divided by 2 is 16, which we then found that the square root of 16 is either 4 or negative 4, which can be both of our x's. Then we plugged both of those in to either equation. First we did a positive 4 squared minus y squared equals 3. Then we got subtracted the 16 from that side and the 3 from that side, and we got negative y squared equals negative 13, and the square root of 13 is negative square root 13, which is our first y, and the same for our second y, just with a negative 4, as you can see there. On to the next standard. Deriving the equation of a circle and graphing a circle. The circle to the right is a perfect starter example. The center is the first thing we need when deriving the equation from a circle. The center of the circle is the origin 0, 0, which is in the middle of the graph. Then you can find the radius of the circle by counting from the center to the edge of the circle. The radius of the circle is 6, as we can tell by counting from 0, 0 all the way to negative 6 or positive 6, or to the y's of 6 or negative 6y. To write this equation with the information we are given, we'll use the formula x minus x squared plus y minus y squared equals r squared. X will represent our x coordinate and y will represent our y coordinate, and r represents our radius of the circle, obviously. So for our circle above, the equation is x squared plus y squared equals 36. The reason this being is that the origin is 0, 0, so we had to plug nothing in for the x's or y, and the 6 radius had to be squared, which equals 36. So 36 actually isn't our radius. To find our radius, we'd have to square root 36 to find 6, which is our radius. So our first example is, what is the radius and center of this circle? As we obviously see, it's not as complicated, just a little bit different than the last one. So pause the video if you think you can do it, or we're moving on to the next, or on to the answer. So the center is the origin 0, 0, and the radius is 4 units, obviously. The reason for the radius being 4 units is because from 0, 0 to x4 or x negative 4 or y4 and negative 4 would be our radius of the circle. Next example, write an equation for the circle with the information you found referring back to this graph right here. And if you think you can do it, pause the video now if you feel free to do so. And we're going to be moving on with the answer now, which is x squared plus y squared equals 16. The reason this being is 4 squared is 16, and to find our radius, square root of 16 equals 4, which is true. For this one, I wrote out the answer already, so I can explain it better. When writing equations that have different centers than coordinates 0, 0, you will be putting the center coordinates in the corresponding variable. Find the center of the circle and its radius and form an equation with the information you found. The center of the circle is a lot harder to find. You can hardly tell that it's actually -1, 2, and then the radius is 8 once you found it. So what we did was we took -1 and plugged it into the second x spot of the circle and got x plus 1 squared plus y minus 2, where we took the 2 and put it in there. The reason for it being x plus 1 is because the -1 is negative, obviously, and so that gets rid of the negative or the minus that was in there, which would become a positive 1. And 64 being because 8 squared is 64. On our next example, now that you've learned how to derive the equation from a circle, it is time to graph circle with the equation. Graph a circle with equation x squared plus y squared equals 4. Now you've probably seen this in the past, so I'm sure you guys can do it. Pause the video if you feel like you can do it. I'm sure you can, and we'll be moving on with the answer now. As you can see, it's quite small. Starts in the origin starts in the origin basically, and has a radius of 2. On to the next example, graph a circle with the equation x minus 2 squared plus y minus 1 squared equals 9. We have to find the center and the radius here. So pause the video if you want to graph now, and we'll be moving on with the answer. So you can see that the center is at 2, 1, and that the radius is 3 of each side. When graphing the equation of the circle, you will have to make sure that the terms x squared and y squared are on one side by themselves and the radius squared is on the other. Draw a circle with the equation x squared plus y squared minus 9 equals 0. This one's going to be a little bit more complicated, but I'm sure you guys can figure it out. Pause the video if you feel like you can do it. If not, we're going to be moving on with the answers now. So what we first did, we got 9 to the other side by adding 9 from one side to the other, so we did add 9 on both sides. We got x squared plus y squared equals 9, and the radius of, or square root of 9 is 3, so we got our circle here. So origin 0, 0, and the radius is 3. On to our next standard, writing and graphing equation of a parabola. This is where it gets a little bit more complicated. We have our standard form, y minus k equals 1 over 4p, and parentheses x minus h, in parentheses squared. And our other way to do it, find things easier, is our vertex is h, comma k, as you can see from the top equation, and our focus is h, comma k plus p. So you would take k plus p and add those together, and that would be your focus because h is already given to you. So on to the example. For this problem, the focus is 1, 6, and the directrix is y equals 2. So I've given you some hints at the top with the vertex equals hk and focus h, comma k plus p. So we'll get on to the answers. If you feel like you can do this, it's a little bit more complicated than the others. We'll be moving on with the answers now. First, you want to set the problem up. It kind of looks like that distance formula, but in reality, it actually is two distant formulas added together. There's actually supposed to be a second distance formula there. Pardon me, after the equals on the first setup, there's supposed to be another square root there. So don't think it's just one long one, it's 2 different ones. My bad. But once you've set it up like that, you want to get rid of the square roots. And the reason why we have it set up like that in the first place is because we have to put the focus in and then add your directrix at the end, which we don't know the x directrix at the moment, which we won't put in right now. to get rid of the square roots, we're going to have to square the whole entire square root. So I put both of them in parentheses. As you can see, I put both of them in square roots this time. I forgot last time, so we got rid of the square roots, and now we have x minus 1 squared plus y minus 6 squared equals x minus x squared plus y minus 2 squared. The x minus x on the second part of the equation cancels itself out, so you can get rid of it. Now move y minus 1 to the other side, or y minus 1 squared to the other side of the equation. So we would subtract the y minus 6 squared to the other side by doing x minus 1 squared plus y minus 6 squared equals y minus 2, which will result in x minus 1 squared equals y minus 2 squared minus y minus 6 squared. A lot of squared in that equation. We'll move on to the next step of the equation. Now, there's a lot of steps, but we're getting there. Next, we're going to factor y minus 2 squared and y minus 6 squared, and get x minus 1 squared equals y squared minus 4y plus 4 minus y squared minus 12y plus 36. A lot of number stuff, but we're almost done, as you can see at the bottom. Next should be the negative 2y squared minus 12y plus 36, and you'll end up with minus y squared plus 12y minus 36. And then you want to add both of those together, both of the y's that we factored out, and get x minus 1 squared equals 8y minus 32. Then you want to divide the whole equation by 8, yes, the whole equation, and you'll end up with 1/8 x minus 1 squared equals y minus 4/8. Then we want to add 4/8 to both sides to cancel out the minus 4/8 next to the y, so the y is all by itself, and we'll end up with 1/8 x minus 1 squared plus 4/8, and that is your answer. On to the next part. I do say so. Now you want to graph our parabola from our last equation right here. So pause the video if you feel like you can do it. It's a little bit easier, a little bit harder, I think. Pause the video if you think you can do it, and we're going to move on with the answer. Now, we had to do it on a different graph because we had to actually draw the parabola on there, and it was a lot harder. So, but that's the answer for your graphing. You can check it, pause the video and look at it, but we're going to move on. When depicting whether or not a shape is a certain shape, you need to use coordinates to check it. The formula of a midpoint, distance, and slope can assist you, such as the midpoint formula, the distance formula, slope formula. These all are very helpful, and you'll see why. For the first problemo, what geometric figure is to the left? Solve using geometric line formulas. You can use the distance formula here, or you can just count the units, but whatever you feel like necessary. But distance formula is always correct. Most of the time, if you just human error, that could help. That could be a problem. But we're gonna move on with the answers now. Obviously, it's a square because each side has 11 units. You can count them, distance formula them. That's a verb. So yeah, each side's 11 units long. Now for this one, we're going to graph a rectangle with coordinates as such: -2, 2, 2, 2, -2, 0, and 2, 0. Draw its diagonals after constructing the rectangle, and then prove that its diagonals intersect. Pause the video if you feel like you can do this. Sure, you can, and we're going to move on with the answers. So first, we made the rectangle, not on the coordinates exactly, but as close as we could get them. Then we made the first diagonal, then we made the second diagonal, and then we used the midpoint formula and found that each one met the middle. Like they each crossed at the middle. That's where they crossed. That's their intersection. And this is a rectangle because their diagonals kind of intersect, meaning that it's equal. So their sides are different. Now I have to prove that these lines are parallel. Pause the video if you can do this, and we're gonna move on to the answers now. The points on the lines are -3, 5, and -7, -9. So what we did here was we found the slope of these lines by subtracting them and yeah, so we did the first line on the left. It has a slope of 14 over 4, and the points on the lines on the right line are 5, 5, and 1, -9, and we subtracted them once again, and we found that the slope is 14, 4, meaning that these lines are parallel because they go 14 up and 4 over. Solving or on to the next standard. Solving or proving circles and parabolas is similar in context. You can prove a circle by taking the coordinates given and plugging them back into this equation, x minus x squared, y minus y squared equals r squared, and the coordinates will have to equal r squared. First example, write an equation for a circle that passes points -1, -6, -1, 10. Find the radius. We're going to be moving on with the answers. Pause the video right now. X plus 1 squared minus y minus 2 squared equals 64. We had to do a little bit of math to find this one. We obviously knew that the x had to be -1, so we plugged that one in already. Now for the y, we had to find the midpoint of -6 and 10. So I subtracted added -6 to 10, which equals 4, and then you divide 4 by 2, and that's the midpoint of them, or midsection of them, and that would be our y. Now, I plugged in those two coordinates, or both of them, tried both of them, and I found that they are equal to 64, and that our radius is 8. On the next example, do points 2, 4 pass through equation x minus 4 squared plus y minus 2 squared equals 16. Yeah, we're going to move on with the answers now. Pause the video if you feel free to do so. The answer is no, because when you plug in the coordinates 2, 4 and back into the equation, you find that it's you get the product 8, not 16, which you need it to equal 16. So it's not true. 2 points 5, 5 pass through the equation x minus 2 squared plus x minus 9 squared equals 25. So take 5, 5, plug it back in, and we'll find out the answer right now. Yes, because 25 equals 25, which is true, because 5 minus 2 equals 3. 3 squared is 9. Then we plugged in the 5 with the x minus 9, or y minus 9, my bad. That's supposed to be y, which equals 4. 4 squared is 16. 16 plus 9 is 25. When proving parabola, you have to prove that a line drawn from the focus to any part of the parabola is equidistant to the directrix line. You can use distance formula to prove this. For the first example, the vertex of this parabola is 0, 1.5, and the equation is y equals 1.1 x squared plus 0x plus 1.5. Is this parabola equation correct? Directrix is y equals -1 and the focus 0, 4. Moving on to the answer now. Yes, because the vertex 0, 1.5 is in the middle of the directrix and focus. -1 plus 4 equals 3. I'm doing this because of the directrix is -1, and we had to add 4 from the focus because those are both the y's. And found 3, and we had to divide 3 by 2 and equals 1.5, and that's the midsection, which is in our vertex 1.5. The vertex of this parabola is -1, 6.5. Is this parabola correct? Directrix is y equals 2, and the focus is 0, 10. So we'll do the same thing over again, but different numbers. Here's the answer. No, because the focus and directrix do not contain the vertex in the middle. 2 plus 10 equals 12, obviously. And we're getting this from the directrix 2 and the focus 10. And then you have to divide by 2, which equals 6. And our vertex clearly states that its y coordinate is 6.5, not 6. So no. And that's the end of our video. I hope this helped, guys. But that's all I have for you today.